Hello and welcome back to this course, covering the exam topics for the JNCIS ENT certification. In this section of the course, we're reviewing Layer 2 security and loop prevention. In this lesson, we'll be demonstrating the configuration and monitoring of 3 Layer 2 security protocols: DHCP security, dynamic ARP inspection, and Layer 2 firewall filters. In this demonstration, we'll first review the current topology diagram, and then the configuration steps and goals before we jump into the live devices. So, let's get started. In this lab demonstration, we have 4 devices. On the right, we have a VSRX, which is configured as a DHCP server. In the middle is a virtual EX switch, and on the left, we have another VSRX configured as a DHCP server. In this case, the DHCP server on the right is our trusted corporate DHCP server. This is the device that our network administrators have configured and has the correct routing information for our enterprise clients to function correctly on the network. The DHCP server on the left is called a rogue DHCP server because it is one which is not intentionally placed on the network by the network administrators. A rogue DHCP server appearing on your network can simply be an accidental configuration from a junior network administrator, or could even be a mistake from one of the staff members in the building. I will personally hear a story at least once a year of a staff member bringing in a wireless router from home to boost the Wi-Fi signal in their office area, not realizing that these home wireless routers always run DHCP servers and accidentally start handing out addresses to everyone in their area of the network. Rogue DHCP servers can also be malicious. Bad actors can use a rogue DHCP server to direct traffic through their own device, allowing them to intercept the information. Often, the traffic will be routed on to the real default gateway, so no one is any the wiser, since everything appears to work as normal. The only way to know that this is occurring is to look at the IP address assigned to the client computers and see that they are not assigned addresses in the correct range, or that the default gateway or other information is not set as expected. Regardless of whether the presence of a rogue DHCP server is accidental or malicious, it poses a risk to our corporate network. So, we'll be putting measures into place to mitigate that risk. Finally, the device at the top is actually a VSRX, which will be playing the role of a client computer, so we can see how the configurations will affect the connectivity. So, now that we've reviewed today's lab topology, let's review the configuration goals and instructions for this demonstration. In the first part of the lab, we'll configure DHCP security. First, we'll review the starting configuration on the EX switch and the DHCP server, and then we'll proceed to configure DHCP security on the EX switch. Once configured, we'll use the virtual PC to attempt to obtain an IP address by DHCP and review the effects on the DHCP security database on the EX switch. Then, we'll configure the rogue DHCP server and try obtaining an IP address again and see what DHCP security shows when we see the untrusted DHCP offers coming from the rogue DHCP server. In the next part of the lab, we'll configure dynamic ARP inspection. Recall that DAI is used to ensure that ARP messages which contain information that doesn't match the DHCP security database are dropped. This will mitigate ARP poisoning attacks, as well as ensure that only devices which have been assigned an IP address by the corporate trusted DHCP server are allowed to communicate on the network. In this part, we'll configure a static IP address on the rogue DHCP server and ping the virtual PC. We'll then configure DAI and try pinging again after clearing the ARP table and see what happens. In the final part of this lab, we'll configure a Layer 2 firewall filter. This firewall filter will block all traffic sourcing from the virtual PC's IP address. The filter will be applied, ingress on the VLAN on the EX switch, and will then review the effects of the filter. So, without further ado, let's get started. First things first, we'll take a look at the starting configuration on the EX switch. Like in previous lab demonstrations, we have a bare-bones configuration, with the lab user configured and some default configuration. Moving down, we have the management interface, GE000, configured, and 3 switch ports, all configured as access ports in the VLAN named LAN. Moving down further, the multi-chassis and protocol configuration is default on the virtual EX device. And we have our default route for management access. At the bottom, we see the beginning of the LAN VLAN configuration, and it's configured with the VLAN ID of 100. Now, let's take a look at the DHCP server device. Similarly, we have a bare-bones configuration with the lab user and other default configuration. One key difference here, though, is the DHCP local server configuration here. This configuration will run the DHCP server and respond to messages received on GE001.0 if a pool of addresses are present. Moving down, we have the management interface configured and the LAN interface. The default route is configured for management access, and towards the bottom we have the beginnings of the address pool configuration needed for our DHCP server. We have that the pool is named LAN and will assign addresses in the range of 10.0.0.10 through 10.0.0.100. This will not assign any other configuration by DHCP as it stands now, like the default gateway or DNS servers, though this is sufficient for our purposes. Finally, let's take a quick look at the virtual PC's configuration before we start configuring the EX switch. This device has very minimal configuration, only a lab user and default configuration otherwise. Moving down, we have the management interface and the LAN interface, which is currently disabled, and configured to obtain an IP by DHCP. When this interface is enabled, it will attempt to acquire an IP address by DHCP. So, let's move back over to the EX switch and start our DHCP security configuration. DHCP security is configured under the forwarding options configuration hierarchy of the VLAN which we want to configure DHCP security for. Here, we're setting GE001.0 as part of the interface group named Trusted. This is the interface connected to the corporate DHCP server. In order to exempt the interface from DHCP security checks, we need to apply an override to the interface group. The trusted override is used to bypass the DHCP security and allow server-side DHCP messages to be received and forwarded on this interface group. Let's go ahead and commit this configuration. Now, let's re-enable GE002 on the virtual PC so that it will attempt to obtain an IP address by DHCP and exchange some DHCP messages so we can see the effect on the DHCP security database in the EX switch. Now, we'll need to give it a few moments to obtain an IP address. Great. We see that GE002.0 is currently assigned the IP address 10.0.0.15/24 by DHCP. Since we've configured DHCP security on the EX switch, the switch should have inspected those DHCP server-side messages and created a binding record, mapping this virtual PC's interface MAC address to the IP address it was assigned. And there it is. We see here the IP address that was assigned, the MAC address of the client which was assigned the IP, the VLAN the mapping was seen on, the time in seconds until the DHCP lease expires, the current state of the binding, and the interface that the client was seen on. Now, let's take a look at the statistics information available. As we see here, we have statistics on the DHCP messages this switch has seen and inspected. Since I performed some testing in the lab environment before we got started, we have more messages here than just what was exchanged for the virtual PC to be assigned the .15 address. We can see the number of discover, offer, request, and acknowledgement packets, as well as many other types of DHCP messages. In the section below, we see the packets dropped statistics. This will be important when we configure the rogue DHCP server, as these counters should increment as the DHCP messages originated from the rogue DHCP server should be dropped. The remaining sections we are not concerned with and are only relevant in multi-chassis link aggregation group configurations. Now, let's take a look at the statistics on the corporate DHCP server. The received DHCP messages are in the top section and sent DHCP messages are in the bottom section. We see here that one DHCP discover message was received, a single offer was sent in return, a request for the offered address was received, and an acknowledgement returned. Now, although having access to the DHCP binding information and statistics on our switches is a pretty cool feature, let's test to see if the situation we're looking to mitigate is actually mitigated. Let's configure the rogue DHCP server to respond to DHCP discover messages and see what happens. We see that the interface connected to the EX switch is configured with the 172.16.0.1 IP address. So let's configure an address pool for our DHCP server using that network. We're setting the range of addresses that can be assigned by DHCP to 172.16.0.10 to .100. Now, we just need to configure the DHCP server to respond to messages received on the GE003 interface, the interface connected to the EX switch. Great. Now let's go back to our virtual PC and release our IP assignment and try to get a new IP address by DHCP. This will cause a new DHCP discover message to be sent, which will be received by both of our configured DHCP servers. We'll need to give it a few moments to complete the DHCP exchange and be assigned an IP address. Great. We were assigned the address 10.0.0.16, confirming that we received an address from the corporate DHCP server, since it's not an address in the 172.16 range. Let's jump back to our EX switch and take a look at the DHCP security statistics to confirm that the DHCP messages from the rogue DHCP server were dropped. Great. We see that the dropped packets has incremented, confirming that the DHCP messages from the rogue DHCP server were dropped and not forwarded, which ensured we received an IP from the correct DHCP server. Now let's move on to the next section of the lab and configure dynamic ARP inspection. For this section, we'll statically assign an IP address to the rogue DHCP server in the same subnet as the virtual PC and corporate DHCP server. And we can ping the virtual PC successfully as expected. Although we have DHCP security configured, this would not prevent any device from being statically assigned an IP address on the network and communicating successfully. Let's configure ARP inspection and see how that changes things. DAI is configured with a single line, ARP-inspection, under the DHCP security configuration hierarchy. Now, moving back to the rogue DHCP server, we see that the pings are still successful. This is because ARP messages are only exchanged once in the beginning of a data stream, and then each time the ARP entry times out. Let's clear the ARP table and try pinging again. We see that the pings are no longer successful. Since DAI has been configured, any ARP messages from a device which does not have a corresponding DHCP security binding entry will be dropped. As such, the rogue DHCP server has no way to learn the MAC address of the virtual PC, since its ARP requests are never making it to the virtual PC. Same of the virtual PC, it is unable to ping the rogue DHCP server, since the ARP requests from the rogue DHCP server are dropped before they reach the virtual PC. The rogue DHCP server is not able to respond to the pings. Let's see how the statistics information is displayed on the EX switch. We see that the interface the rogue DHCP server is connected to has sent 33 ARP messages, which have failed ARP inspection. And if we enter the command again, we see that the rogue DHCP server is continuing to send ARP requests, which are being dropped as this counter is incrementing. Great. Now let's move on to the last part of this lab demonstration, where we'll configure a Layer 2 firewall filter. First, just to validate this is working before we configure the firewall filter, let's ping the DHCP server from the virtual PC, which is successful. Now, we'll configure a firewall filter for the family Ethernet switching. This is the protocol family that defines the firewall filter as being a Layer 2 firewall filter. The filter is called L2_filter_1, and our first term is called deny 10.0.0.16. In this term, we're matching traffic with a source IP address of 10.0.0.16, and we're discarding the traffic. We'll create one more term which will allow all other traffic to pass. The filter is applied ingress at the VLAN level. This is done at the forwarding options hierarchy of the VLAN you wish to apply the filter on. Great, this looks good. Let's go ahead and commit this configuration and try to ping again from the virtual PC. And there we have it. The virtual PC is no longer able to reach anything, as long as it is assigned the 10.0.0.16 IP address. Just to validate, let's go ahead and roll back the firewall filter configuration and confirm this allows us to ping again. And there we go. We're able to ping once again now that the firewall filter is no longer configured. This concludes the Layer 2 Security Lab demonstration. I appreciate you working through this lab exercise with me. The configurations for the devices are included with this lesson in case you'd like to configure your own devices to follow along. I hope that this lesson has been informative for you, and I would like to thank you for viewing.